Okay, so we're online with Grenoble. Can you hear me well?
Yes, very well.
Okay, good. I guess we have something like 2 hours, 1 hour and a half. How much time?
Yes, very well. I guess we have something like 2 hours, 1 hour and a half. How much time? Yes, very well. I guess we have something.
Rami, can you hear me?
Yes, we can hear you.
So how much time do we have?
1 hour and a quarter and a bit more. Just because then we would like probably to
discuss. Okay, great. Then I will start explaining a bit this idea, and then I will start writing some code as well. Whenever you have questions, please ask. There's a lag, and that's because of Twitch and the live streaming, but I didn't find a better way to have this better quality stream like that. So we'll see how this goes. TDD as if you meant it was invented by a guy called Keith Braithwaite from London, and his idea is that you can write code with TDD in a way that forces you to have very small steps. That means you need to respect these rules that are on the screen. First of all, you write as any TDD or you write a test, but then the weirdest thing is that you want to make the test pass by writing the implementation code in the test method. That means that you're not allowed to create any new classes or methods that you test. So in a traditional TDD approach, you'd have maybe a class or a method or a function, and then you call it, and then you return the simplest thing possible, and so on. So it's this game between production and test code. Well, here what we do is we write the implementation in the test method, and when we spot duplication between the test methods, then we want to extract it in a method. Here we respect a rule called the rule of 3, which isn't in fact a rule, is more like a guideline. And the rule of 3 says extract anything only when you spot it at least 3 times. That is a guideline to stop us from having any type of accidental duplication, and that's why we use it. In the same thing, when we'll see more methods that belong together, we'll try to extract them in a class. So it's a very small step approach towards writing code, and we'll see how it goes. I have my code here. It's not doing anything. I just wrote some test method, and I just want to make sure that JUnit runs well. First of all, the first thing I want to do is, before doing any coding, is to have an analysis of the problem I want to do. And that means that I typically apply a technique called behavior slicing. That means I look at the inputs and I look at the outputs. Now, what's the problem we'd like to start working on? Come on. So let's say we'll have poker hands, in poker hands, what we want to check is if we have some players, we just want to see who wins the poker hand. So we don't care about the whole mechanism of the game in this specific part of poker. We just care about how to detect who won in a specific hand when they showed the cards. So if we look at this, if we want to analyze this problem and we don't have anything we would like to start from, typically what I do, I start with the outputs. So what are the possible outputs of this problem when we have some hands? We might have a winner, and the other possible output is that we might have a draw. I don't know any other output in the case of poker hands. In the case I have a winner, I have a lot of possible inputs of winning. But I want to start with the simplest ones. So if I have two players, and let's say I want their hands to be something like 1, 2, 3, 4, 5. Sorry, let's start like that. 2, 3, 4, 5, 6. And that's for P1. And then P2 has 2, 3, 4, 5, 7. So what does this mean? This is called in poker terms, this is called high card, because I have all these three or these four cards identical, but 7 is bigger than 6, so I will have a winner, player 2. If I have something the same, what's another option of winning? When we have two cards, so when there's a pair of cards. So if we have something like this, 6, 6 and 7, 7, again I would have a winner P2, because the first three cards are identical and the last two, they're pairs, but the pair that is bigger wins. This is, so let's name this. This is called high card. This is called pair. And then we can go on.
Adi, we have a question for you.
Yes, please.
Yes, make a mistake for the first test. It's not P2, but P1 the winner, not?
Yeah, but it's a suite. It's a 2, 3, 4, 5, 6.
Yeah, you're right. So let's change that. It's like that. You are absolutely right. So if it's like that, and it's still not good, right? Because then I have, no, it's okay. Right?
Yes.
Okay, thank you. Okay, so we have this, then we have a pair, and so on. We could go on with things like that, but I think we won't have enough time anyway. So you can go on with 3 of a kind, or you can go on with the suite, and so on. And then there's another idea here when you have a draw, but I don't even care now about working on the draw. What I care about is just working on this, and this means that I want to triangulate on the notion of winning. So what do I want to focus on? Compute winner. If I do this, and it means that all my tests, all my next tests will need to focus on that. So what do I do now? I have an expected and I have an actual that comes from a production system. The expected thing is something like P21. And the actual thing, well, I don't have it yet because I don't have it implemented. So I'd like to extract this into variables. Winner message. I'd like to extract this to an actual, actual variable. And now only for explaining purposes, for didactical purposes, I'd like to comment the areas of my tests, of my test. Because with TDD as if you meant it, we have another part of the test that is special, and it remains here until we refactor everything because of duplication. So what is actual? Well, actual comes from a production. Okay, so if I want to implement this production, basically this is my production code here. If I want to implement this production, that means I would need to give it the two hands of the players. So I'd have something like, oh come on, player one hand, and player one hand is this, for example, and player two hand is this. So here in my production code, I want to use them and write the simplest possible code to see to decide the winner. So I need to find a way. If I would use traditional approach TDD, I would just want to fake it. So I would probably just return P21, right? So I could do that. And that's something I saw people don't get usually. So I could just take this and put it here. But that means I don't pass these two. So my test is just a fake. And I think that's not a good idea, because on the long run you won't understand how to use them, and so you get stuck. So instead, I would like to use those, and this would be in a way like sending parameters to a function. If I would use a function language, it would be very easy to do something like this, okay, and pass to an anonymous function the parameters, and then it's easier to understand what's going on. With Java, where anonymous functions aren't that pretty, I just use the variables directly. So let's do something like player one hand 5, I think. And then I need, well, just let's extract this to variable last card. last card player 2. Last card player 1. Okay. So here I need to make a comparison and do something like this. So this should be I don't remember how to convert this.
Compared to?
Convert it to integer. I forgot how to do this.
Okay.
Oh, c'est integer to
You
string?
can compare the
Integer
characters.
value of.
Value.
Integer value of.
Oh yeah, great. So
You don't need a math. I think that you can use integer and value of.
yeah. Sorry, not return. So I need to do this. Okay, so I forgot the parentheses. So that means number format exception. Oh yeah, it should be 4. Because the index starts at 0. Okay. So this is one option. It's not maybe the simplest code possible to write as in traditional TDD. And I think that's mainly because I want to go a bit faster, and also because Java isn't that functional. I think this approach is a lot easier when we use functional languages. So let's init a git. I will add stuff. First test for poker. Okay, so now what I'd like to do is to see this type of code duplicated around my next tests. So that means I triangulate on this concept, until I have at least 3 duplications, I need to write more tests. I want to rename the test, and I would say something like player 2 wins with high card. Okay, next test. I could also go a bit deeper. Here I only have one test for high card. Okay, and always P2 is winning, and that's not good. So this is just, let's say, an archetype of tests. So that's why I'd like to say that also player 1 can win, so that I don't hardcode, wins with high card. So how do I start this? Let's say we start the same from the assert, or at least I start this like that. P1 wins. And again, I don't know how. This is unexpected. This is an actual. This is a production code. expanding this means that I will want to look deeper into the concepts I have. And this is in a way the analysis that you make while writing these types of tests. Okay, so let's name things a bit the same. Winner message, and then to make this pass, just to test it, it's red. It should be red, right? And now just to make it pass, I'd like to do something like to give it the cards, but let's say here I just copy them, but here I will have 9 instead of 8. So in order to make my test pass, let's do a bit the same. Here I call them last card player 1. So last card player 1 is player 1 hand, substring of 4. And it should be the same with player 2 hand, last card player 2. And then I say teacher, value of last card player 1 should be bigger than integer value of last card player 2. And in that case, production should be something like P1 wins. Let's run. Oh, sorry, forgot this. Okay, let's run the tests. Okay. So I have some duplication I can already observe around here, like this part, but I only have it 2 times. And it's not really duplicated, because here I have smaller than, here I have greater than. Here this message is not really the same. Let's use the same name anyway, at least. So I want to write at least 1 or 2 more tests, and then I'd like to start refactoring. So let's run the tests again, because I changed a bit of things. And then I will make a commit, added second test, player 1 wins with high card. Okay, I could just go on with high card, and I can observe that because of this operation I have in fact two areas to triangulate to, when player 1 wins and then when player 2 wins. And that if I can observe also that the type of operation is related with the player, which could or could not be, I don't know exactly, an accidental duplication. So as long as I don't know that, I want to continue writing tests. Also, here I have a special situation that my cards are always in order. So this is an assumption, I didn't test it. And when I have such assumptions, especially with TDD as if you meant it, I want to note this down, because you might forget and then who knows what happens. So I'd write something like to do test the fact that cards are always ordered in a hand. I've done this because I don't want to focus on ordering them. Also, I only use numbers. I don't use the letters from the cards. And that's again for simplification. So let's write a new test. Public, come on, void player. So what could we do now? We could go on to pair, but I think we didn't triangulate enough. We don't have 3 things that are duplicated, so I would never go to this now. It's too early. I don't have enough proof of duplication in between the tests, so I do need to continue on that. I can come up with some other examples of cards, and I could just go and pick up this, for example, identical it is. Typically I kind of tend to write the tests, but because we don't have that much time, I will just copy paste this and change it. And we'll see the name of the test a bit later. So if I'd have this, let's say I have something like that, but that's, yeah, it's fine. So that means player 2 wins with a high card again. With other high card, and that means I will do this, this, and here it should be P2, 1. Of course, something's wrong. That's what happens when you cut corners. So it should player 1, oh no, player 1 should win. Yeah, because player 1 has the bigger card. And it should be like that. And like that. So what's wrong? Player 1. Player 1 has this hand, 9 should be bigger than 8. Player 1, player 2. I don't get this. Okay, here.
Could you show us the error message to be sure that it's this?
Oh, I was working on the on the wrong test. That's the
Yes, I think.
Yes. So which one was? Yeah, okay. That makes sense. So here in this case, player 2 wins. Player 2. So if player 2 wins, it should be like that. And it should be like that. P2-1. That's why I say cutting corners is never a good idea.
Yes, and it's P2, not P1.
Yeah. Edit third test. Okay, so now if I look at this code, I want to respect the rule of 3, and I understand that there are some there's some duplication, but there are still some things I don't know yet how to get rid of, like this difference. These aren't exactly identical, but these are. So I want to make this part the production. That's the production, that's the actual. Okay, I want to make this part of production code identical, and let's do some refactoring. I have some duplication here. What is this for? What is for meaning? This is index of last card in hand. So I want to start making explicit all the small variables and primitives I used. Okay, so I extracted this. My typical approach is to extract these in functions, but as we discussed also in Socrates, you can do this as well in constants. But typically, I like just to extract this in functions. So it's something like that. And then if idea says I have two other the same, that's great. That means I'm doing what I want, and then I can inline these variables. What happens now is that the code becomes more you expand the code, and it becomes larger and larger, harder to read, because I extract these concepts, and after a while it will get compact, and even more compact than was in the beginning. So it's a specific approach of doing this.
Is good.
Okay, all is good. Now, the fact that I have index value of, that's a comparison, right? So I want to, that's a transformation. I want to transform from one type of representation to the other. And I have this at least 6 times. So as I told you, if I use the rule of 3, I'd like in a way to extract this as well, because it exists all over. So I will call this something like yeah, I need to extract it all. I will call it something like get card value. And it says yes. I found it all over the place. Okay, good. I like to keep my my methods extracted at the top, because at the later stage I will extract them, so if they are in the middle I might forget about them. Okay, what next is duplicated here? I have these things. This means what? This means get my last card. So if I would extract this, get last card in hand. And again, I have duplication. And I can inline this. And I can inline this. And this as well. So my code is a bit simpler because I extracted these things. Let's move this to the top with the others. I still have the comparison and I still have the message. That's a bit the same. So now I want to understand what is the connection with this. Last card in hand of player 1 hand. In this context, player 2 1. I would extract first of all this to a method called get player 2 winner message. You can do in a lot of ways this thing. I just want to focus mechanically on removing duplication. You could have just split that in two and that just extract the one part, and then the other one you'd extract it in another way. But here, if I've done this, what I see is that here I don't have it 3 times as the rule of 3 says. So typically I need to think very well. Is this accidental duplication or is this structural natural duplication? And I'm quite sure it's not accidental. So this is why I said the rule of 3 is a guideline. And I will just extract this as well, like I've done with this. Let's move this to the top. But be very careful when you understand if it is accidental duplication or not. Okay. If I continue like that mechanically, I could just extract this in the case when player 1 wins, and we're on the first test, right? Was, let's say, no, the last one. No, so if I go mechanically, I would go with this. When player 2 wins, extract this because this is identical duplication with the last test when player 2 wins. But I don't have it 3 times again. Or what I could do is I could try to make these things identical, and that means I need to extract this in something. So if I extract this, what does this mean? Player 1 has bigger hand. And what does this mean? This means player 2 has bigger hand. And this is player 2 has bigger hand. Okay. Just a moment. Okay. Sorry, just something popped up. Okay, so now I start seeing something. This is about player 2, and this is again about player 2, and the first one, and the other one was about player 1. So that means that I kind of have here more types of algorithms. I kind of see here that we could use strategy and we could inject it some way. Or another thing I could do is just leave it like that and write more tests to have more proof of what I need to do. Anyway, I have two different areas of code. This is about comparison, and this is about getting out the winning message. So if I look at this comparison thing, I could extract it from the tests I already have. I don't have 3, so I would write more tests. These ones should always remain like that, because this is just test data, so I would never extract this to something else. Okay. Let's move this to the top. Do some cleaning up. Oops. Okay, all is green still. So what I'd like to do is continue writing tests, because I don't have enough duplication on this one. Player 2 has bigger hand. This exists here, but and in the last one. So I'll rename this test to be a bit more precise. and I need another test. As I said, normally I would write it, but we are kind of pressed with time, and when you're pressed with time, you just cut corners. Don't do this at home. So that if I would write again another test, I would end up to having something like this. Okay. And that means I could extract this to a method player 2 has bigger hand, and I have another 2 fragments. Let's move this. And again, I can inline this. And not to player 1, I didn't extract this yet. Let's inline this, and let's inline this. So now what happens is that this code is identical again in 3 times, in 3 places. Now I have a choice. I either continue with extracting this and refactoring more on this path of player 2 winning, or I write more tests on player 1, because here I didn't have enough duplication yet, and if I would do that, I would try to extract both from player 1 and player 2 case, and then try to merge those in a way. So yeah, I will just extract this now, and I will call the method getWinner, and again I have it in other places. Winner. Okay, move it to the top, and now I don't need these anymore. I don't need this production thing anymore. I don't need the actual thing anymore. But I would keep definitely the settings as they are. Here this is for player 1, so I would need to wait a bit to do anything. So let's inline. And inline again. I would move this test to the top because I want always duplication to be closer. And I'd like these tests that are about player 2 to stay one next to the other, and the text with player 1 could wait a bit, so I just put it on the top. Now if I have this, I'd like to look at the duplication I have here, and if I could extract something. So again, I have 2 options. I could continue writing tests on player 1 and extract the duplication, or I could continue with refactoring with this specific very narrow case of player 2. I'll refactor a bit more, and then probably the time will be up. I won't be able to show you the other part as well. Here I think I could get rid of this. Yeah, I cannot inline it, but I could do something like this and like that. And obviously these ones, these two, and get card value and last card in hand, I think in my view they should be together. So now as the rules say, if you have at least 3 methods that belong together, you can extract them to the class. First of all, make them static, because I'd like to extract only functions that are pure. For me, this one is more of a setting. It shouldn't belong to the class, so it says it has data, it has values, so I don't want to extract that there. It's the same with this and this. These are settings for me, so I'll put them on the top. They don't have logic, so because they don't have logic, I won't use them. This is against these are again the things that I'm using, and now I can see that I have a dependency. So obviously, because I cannot extract because of these, and why? Because get index of, yeah, so it's the same. That shows already the degree of dependency injection I need to do, because this shows me that when I want to compute the winner, I need to inject the messages. Because this is, I made this static, I try to make it a pure function, but it's not a pure function. It needs something from the outside. So I think I could do is I could promote this as parameter, and I never know how to do this. Nope. Yeah, anyway, I will do it like that. Player, the type is string, the name is player to winner message. Oh, again, once more. So change signature, type is string, the name is player to winner message, and the default value I'd like to be this, the method. So here, instead of using that, I will use player to winner message, and now it's not complaining anymore. Let's see where a usage is. So I'm passing this here, and that's fine for now. It's just a temporary situation until I can extract it, and then I could inline them again. But that shows the level of dependencies and the flow of dependencies. So now, because I've done this refactoring in small steps, I understand what I need to do, and I understand which are my dependencies, and I can get them right. And let's do the same with this. This is int index of last character. Well, it should be like that, but oh no, the last card in hand. Yeah. So again, so that means here again I would need to do the same. So you can see now only from the level of methods what is the flow of dependencies, while I try to extract these as pure functions. Nope, it doesn't want to help me. So again, get index of last card in hand. Teacher. Okay. And now, no, I need to add it here as well. So one more step. Teacher. Index of last card in hand. Okay, let's see if I run the test now. Okay, also that means that because I had this situation, I didn't do enough preparatory refactorings. I didn't see enough of the duplication that existed there, and I rushed a bit with extracting bigger methods than I should have. This situation can happen quite often, but again, you need to listen to the tests and look at the dependency flow, how it looks. Okay, so what I want to do now, I want to extract all these functions, pure functions, to a class called poker cards compare. Okay, so I extracted it here. I have static calls all over, and I'd like to change that to having just object calls. So I want to make before, and I'd like to instantiate this. And now, because I have the same name, I'll just camel case as it should be called. And And now, because I don't have static calls anymore, I can just remove the static. Okay. So I have my first class extracted. Here I don't have 3 yet. As I said, probably I would wait until writing the draw tests and extract this one as well. But so that you understand what I would do after that, I do something like this, like the same. Again, they are pure functions, and I would extract this to a class called something like poker message. Maybe it's not the best name, but I will live with this. And again, poker message. I'd like to instantiate this. Okay, rename it. And now what happens is that this winner message gets passed like that, but I'd like just to inline this. And well, here it's not that important, but here it's a bit more important, because here I've done the work and I extracted the methods. So now that shows me that if I'd like to really work object-oriented, I would need to have to inject poker message to the poker card comparer. Let's run the tests. How are we on with time? Do you want to stop?
Perhaps we can make just a break to see if we have question, because yes, it's 1:20. So perhaps it's better if we have question and just ask to you, and we will see, because not sure that we will have time to go further in the code. I don't know.
Okay.
So perhaps, I don't know if someone has some question or just some feeling. No? Me, I have just a question that when you want to show the duplication, to be sure that is not an accidental duplication, we try to make 3 times the same code. And for that, we use the parameter, the variation on the parameter, the input. And I wonder if we really need to do it, because we just copy and paste and just create a new test just to show the duplication, but I'm not sure that it help for the test if we have a test view. So I wonder if we just create the new state just to show the duplication, but it don't help so much. So I wonder, I'm testing by your view about it.
Well, I think that in this case it's quite simple, and you could duplicate it. The fact that you could duplicate the test shows that 2 is enough. But in other cases it's much more complicated, and you couldn't even duplicate the test. But
yes, I think that this kata, or don't see it very well because we just change parameter value, and so we create something like a fake duplication. Not we can't see that we have a real duplication between different behavior. So it's why I wonder this.
Yeah, but look, between the player 1 and player 2, you'd say that it's the same code, but in fact it's not. So I couldn't extract it. That's often a surprise. So just the fact that we put those two together, that showed that it's not really the same thing, and the way you compare the two are different. But with the other one, you're right. I agree, and that shows that you don't need 3 times duplication. I just wanted to show you how you do it. It's just the fact that I can fake the duplication the third time. It's making my point stronger that I can remove the duplication. If I couldn't have duplicated that test with other data, and I couldn't have had the same type of production code, that meant that I need to search for duplication in other place.
Yes, I think that the question I have is that it seems that I would create this test just to follow the constraint, not because I wanted to create the test. Is why I wonder this.
Well, I don't want to follow the constraint. I just want to have enough proof, and I want to be sure enough that what I do is on a good path, and I don't rush into refactoring too fast. That's the only thing I'm concerned of. And here it's about how well you know the domain and how trustful you are on your instincts. With this technique, you don't. It says from the beginning you don't trust your instincts. You want proof.
Yes, and if you want to create some duplication, because we are just changing the parameter value, perhaps we can use the GUnit parameter or ZOAC library.
Yes, so for these 3 tests, we could compress them now because it's obvious. We could compress them into parameterized tests. So these 3 would become just 1 test. And probably at the end I will have 2 tests. One when player 1 wins and one when player 2 wins. And probably the 3rd test when we have a draw.
I don't know if someone have some more question or no. I think that because we are not a lot of time, it will be interesting. I'll try to say it again. I think that we don't go enough far to see to really see the point and to see how it really help us on the production code or work. And I think that we can see the start, but we need something more. I think to see that yes, it's really one practice. It's very interesting to use, and because I'm not sure for the moment that the production code is a good one, is a good design, or we can have a better design. I don't know. It's a design, but it is the best, or it is easy to maintain and to use by other one. I don't know for the moment.
The purpose of this way of writing code is to make you go in small steps so that you don't do mistakes. And if you know your domain very well, this type of working is not something that is very useful. But when you don't know the domain, or when you don't know exactly how you need to work, what you need to do, it shows you exactly what are the dependencies. As you saw with this thing with dependency inversion, the fact that I saw it just from the proof, just from the fact that I couldn't make a pure function, that shows me, okay, that means I need to inject a dependency. So if you look at things like that, you'll start seeing the flow of objects. And after that, if you see the duplication here, you'll understand that because I have the player 1 and player 2 tests are a bit different, you understand that probably there's a strategy there. And it's something you need to inject if you want to have open-close principle respected. And the strategy is of how you compare the cards. You can understand those without necessarily looking at this type of duplication and the flow, but this technique helps you with smaller steps.
Yeah, I would. I like not to jump so much to the conclusions to how I can use it in real life.
Mm.
For instance, I do not yet use creating duplication in tests. A lot generate duplication in the production code to help me shape it. So I'm thinking that, maybe doing this a little bit, then it might change my way of working in some way. So I find that there's the really new thing here to me is that I postponed the choice of data structure, choice of what is the data I'm manipulating in the tests until further in the process. Like when we did the tic-tac-toe, do we use a string, an array, or int or whatever?
Yes. But yes, what I like in this method is that we have to prove that you need that it's not an accidental duplication, and we need to make some refactoring and stop the duplication. And the idea that we have a small step by small step. So that's something that I like it. But I think that I really need also more practice, and because as we can saw in the last dojo, it's not just by just this constraint that we have the best path. We can make also some error, and so I think that is just because it's new that we don't master it enough, and we have to practice it. But I like the idea, but I'm not ready to use it whenever I want. I really need some practice.
So you can take the code, I'll post it on GitHub, and try to continue with it, or start all over if you want. I think continuing, well, on Java with it, it would be a bit easier for you.
Okay.
There's one. I don't know how we do that in other languages, but in Java, a way to move a method, like there's we can create an object, a member of the test class. So I just try this here now. So I create new poker as a member of the test class, and then I can move the instance methods to that class without any.
Yeah.
But that depends on the ID and the language, of course.
So you don't need to use a static method to write?
No.
But I think that when you use the static, it's just to see if you have a pure function or not. It's not just for the refactoring, automatic refactoring. I think that it's just a little bit more than just to help the IDA for the automatic. Is to be sure that we have a pure function, So we need some dependency injection.
Yeah, that can help. Yeah, that can help. On the other hand, now we have the global thing is a pure function.
Mm.
Like, given these two hands, who wins? But yeah, I agree with you. It's, can help you detect the pure function. Did you, Adi? Did
Yes.
did you see or do some with the Keith Braithwaite
No.
sometimes, or have you detected different styles of doing TDD as implemented?
Yes, I have detected different styles, and each style is different, I think. But I think most of the problems I see is that people fail to respect the rules, and they don't find a way to respect the rules. But of course, there are very different styles. I go a lot more functional. Some people like to use more state. I go in, I think, a bit smaller steps than others. And I want to focus on triangulation, while others don't focus necessarily on triangulation, but just spot duplication and extract it. So just write test fast, extract duplication, write test fast, extract duplication. So it's like a generating a machine that's generating duplication, adding all these tests, and after that, because you have duplication, you extract the classes, and then you start looking at how they behave. Anyway, what's common, I think, on all the styles I saw is that you need to refactor a lot, and you need to have good tools for refactoring.
Yes. And did you see that someone used this practice in production, but in real production, not just in kata? Or
yeah.
For the moment, it's just the beginning to start to master it, and we are just using it in kata?
Yeah. I saw plenty of people using that, and I think it helps, but it's easy and difficult because you need to understand where it's useful. If you use it when it's not that important, then you just waste time. So it's like any tool, you need to master it. And it's not a tool that's that easy to master. I think everyone who knows TDD could try it out.
And I think that it should be more difficult with legacy code because we already have code, and so I think that it could be more difficult.
Yeah, I think it is more difficult. But the thing is that you don't need that too often. I don't use this too often with legacy code. I just use it as it is here when I surround the code I want to change, and instead of refactoring, I just want to rewrite it with very small steps. So I just extract it, I put some interfaces around it, and then I start using TDD as implemented to rewrite that code again in a simpler way, because I find it easier to rewrite it with TDD as implemented rather than refactoring. That's the only place I use it with legacy code. But the thing that TDD as implemented with legacy code is that you need to take very small steps, and you do need to do a lot of refactorings. And all these refactorings, like spotting out patterns and understanding the flow of dependency injection and so on, all these I learned by using this a lot. So I think it helps you in understanding how to refactor better. You start having this muscle of refactoring because you need to refactor so much. And with legacy code, you do have a lot of primitives often, or misplaced code. Here is the same. You have it from the beginning, and you need to understand how it makes sense to put it together. So I think you can use it, but the refactoring part.
Okay. I don't know if we have something else, or we can stop. So thank you very much, Hadi. It was nice to do it with you. It was very nice, and it was our first remote strong pairing, and it works. So we can try another time. So we can see that we can do it, and it was very nice. And thank you to take times for us, and we will be happy to see you. And perhaps one time you will be with us at Grenoble.
Yeah,
We hope that.
I'll try. Thank you for inviting me.
Okay, thank you very much, and bye bye. See you.
Thank you.
Bye.
Bye.